Okay, 14.2 thermodynamic process. Before we proceed for this subtopic 14.2, so let's say kita tengok dulu untuk 14.3 because dia ada define untuk work done. Okay, sebab nanti you can explain certain part kan. Alright, so 14.3 thermodynamic work. Okay, discuss work done in isothermal, isochoric and isobaric process. Okay, we consider as the gas contained in the cylinder fitted with the movable piston. Okay, so this is a cylinder that fitted with the movable piston. Piston ni boleh angkat dan turun ke bawah lah. Okay, at equilibrium, the gas occupy a volume V and exert a uniform pressure P on the cylinder wall and on the piston. Okay, maksudnya initially lah. Okay, so maksudnya the gas occupy volume and exert uniform pressure lah. Maksudnya pressure dia ada juga wujud dalam ni sendiri. Okay, if the piston has a cross-sectional area A and the magnitude of the force exerted by the gas on the piston is force is equal to pressure times with area. Okay, mana datang equation ni daripada pressure is equal to force over area lah. Okay, by Newton third law. Okay, ni kalau kita move Okay, by Newton third law, the magnitude of the force exerted by the piston also the same. Maksudnya kalau kita turunkan piston ke bawah, so force yang exerted by the piston to the gas adalah sama. Macam Newton third law lah kan. You compress, force yang exert dia adalah sama bila you expand. Okay, when a piston is moved downward, so the small distance dx, okay, akan ada perubahan dx dekat situ at a constant speed. So the pressure of the gas in the cylinder can be assumed remain constant at P because change of x ni sangat kecil. Okay, jadi dekat sini dia katalah work done dW into the gas is given by equation work done is equal to F dot S. Okay, as you know that when F dot S means that we have S cos theta. Okay, Fs cos theta. Okay, so sekarang ni bila kita gerakkan piston tu pada certain distance, so distance yang kita guna adalah dx lah. Cos theta datang daripada mana? Because the dot product. Okay, so kita ada perubahan x, so kita mesti ada perubahan work. Itu memang syarat dia lah. Okay, change work. Okay, delta work is equal to change work is equal to PA is come from force is equal to PA. Okay, substitute force is equal to pressure times area and dx. Okay, so as we know that area times with dx means certain position x. Okay, certain position means that certain length lah. So dia akan jadi V volume. So dW is equal to P dV. Means that change of work is equal to P change of V. Okay, infinite change of volume from V1 to 2. Kita integrate equation ni, kita akan dapat work is equal to P dV. So P dV from V1 to V2. Okay, so work done. P is gas pressure, V1 is initial volume of the gas, V2 is final volume of the gas. So on PV graph, we know that the work done is represented by the area under the graph. So kalau awak nak kira work done, awak boleh juga kira daripada area on the graph PV. Area under the graph PV, dia adalah work done. Okay. So disebabkan kita ada case isothermal, isobaric and isochoric process. So based on isothermal process, kita tahulah dia datang daripada equation of ideal gas where PV is equal to nRT. So therefore the work done which in change of the volume from V1 to V2 is given by this equation. Okay, W kita integrate sebab dia punya case ni change temperature kita constant. Okay, untuk isothermal ni temperature constant. So bila temperature constant, dia ada perubahan volume dengan perubahan P lah. Okay, W is equal to nRT ln V2 over V1. Okay, so kalau kita tengok dekat sini relation isothermal di mana P dengan V1 dia adalah inversely proportional. So untuk equation can be expressed juga dalam pressure where W is equal to nRT ln P1 over P2. Okay, in the isobaric, the work done in which the change of volume from V1 to V2 is given by integrate equation P dV. So where P is constant, so P is come out. So change in V is V2 minus V1. So kita akan dapatlah work is equal to P delta V. This for isobaric. Okay, in isochoric, since the volume of the system remain unchanged, so we know that dV change in V adalah kosong. Sebab dia tak ada perubahan V. So based on work is equal to P dV. So work done for isochoric or isovolumetric process is 0. Okay. So look at 14.2 thermodynamic process. Define the thermodynamic process. Discuss PV graph for all thermodynamic process. So in isothermal, is defined as the process that occur at constant temperature. Okay, when at constant temperature, so based on PV graph, so you can see that the graph is like this. Ini maksudnya expand lah sebab anak panah kita ke sana. Okay, anak panah kita adalah daripada V1 kepada V2. Maksudnya V1 adalah initial volume, V2 adalah final volume. Itulah expand lah. Kalau compress isothermal, maksudnya dia daripada V2 kepada V1. Anak panah dia akan terbalik lah. Yang tu kena faham Okay, kemudian obeys Boyle's law, whereas P1 V1 is equal to P2 V2. Ini adalah based on yang triangle tu lah. PVT. Okay, sekejap. Di mana bila temperature constant, okay, so maksudnya equation kita akan jadi PV. So P1 V1 is equal to P2 V2. Okay, since U is directly proportional dengan T, maksudnya internal energy is directly proportional dengan T lah kan, sebab dia punya internal energy formula adalah F over 2 nRT. Jadi bila T kita constant, maka untuk delta U adalah kosong bagi isothermal. Jadi based on thermodynamic equation, delta U is equal to Q minus W. So, bila delta U kosong, maka dalam thermodynamic punya case bagi isothermal process, Q akan sama dengan W. Heat is equal to work done. Okay, so all heat transfer into the system is converted into work done by the system to the surrounding. Okay, so all work done on the system is converted into heat loss to surrounding. Kalau dia kata work done by the system, heat transfer into the system lah. Kalau work done on the system, so the heat adalah loss to surrounding. Okay, so nanti awak akan lagi faham kalau awak buat example lah. Okay, untuk isovolumetric, dia adalah defined as the process that occur at constant volume. Bila constant volume, graph dia akan jadi graph straight macam ni, ke atas. Kenapa? Sebab volume kita hanya ada satu sahaja. Okay, so changing of pressure lah. Okay, so dia akan obey pressure law. Okay, whereas V constant, dia punya equation akan jadi P1 T1 is equal to P2 T2. Ni kalau equation yang awak nak cari sesuatu nilai lah. Contoh awak nak cari temperature dekat point ni. Okay, contoh temperature dekat temperature 2 dekat sini kan. You boleh guna equation ni. Mungkin dia bagilah temperature 1 berapa. Okay, pressure 2 dia bagi, nak cari temperature 2 berapa. So kita boleh guna. Sama juga macam isothermal ni. Okay, kalau awak nak cari pressure dekat sini, okay, ataupun volume dekat sini, so bergantung kepada data yang diberi. So kita boleh guna Boyle's law. Okay, so untuk isovolumetric tadi, dia adalah constant V. When constant V, kita tahu dia punya work done adalah kosong. Based on apa? Based on equation tadilah. Work done sama dengan P change of V. Sebab dia tak ada change of V, maka work done-nya adalah kosong. Okay. Bila work done kosong, so delta U is equal to Q minus W. So work is 0. So jadilah Q is equal to delta U. So if the heat added into the gas keep at constant volume, all the heat goes into increasing the internal energy of the gas, which is accompanied by the increase in temperature. Kalau terbalik, kalau heat is lost in isochoric process, so internal energy akan decrease lah. So does to temperature. Maksudnya Q kat sini kan, kalau Q awak positif, dia adalah heat added kan. So maksudnya delta U pun akan tinggi lah. Macam tu. Okay. Kalau heat loss dia adalah negatif kan. Jadi bila negatif maksudnya temperature awak tu adalah perubahan decrease lah. Decreasing in temperature. That's why internal energy akan decrease lah. Okay, next adalah isobaric process. Isobaric process is defined as the process that occur at constant pressure. So, bila constant pressure, maksudnya graf awak akan jadi macam ni. Sebab pressure you satu saja, jadi change in volume V1 to V2 ataupun V2 to V1. Kalau case macam ni, dia adalah expand. Kalau anak panah ni terbalik, dia akan jadi compress sebab V2 V2 kepada V1. Maksudnya perubahan decreasing in volume, so berlakunya compression. So, dia akan obey Charles law. Kenapa Charles law? Because pressure constant. So, bila pressure constant, maka equation kita akan jadi V1, T1. V1 over T1 is equal to V2 over T2. So, mungkin awak nak cari satu nilai kat sini, awak boleh gunalah Charles law. Okay, since P is constant, so work is equal to PdV. Okay, based on equation of thermodynamic, so delta U is equal to Q minus W. So delta U is equal to Q minus P delta V. Dia ada semua. Okay, so in isobaric expansion, heat added into the gas is heated and the increasing delta U and the work done by the gas. Maksudnya dia ada semua. Okay, untuk adiabatic is a process that occur without heat transfer. Okay, so kalau you tengok graf dia pun, adiabatic adalah perpindahan daripada dua temperature. Temperature 1 kepada temperature 2. Nampak tak? Macam tu. So, T1 is larger than T2. Kat bawah kan? Okay, so dia tak ada apa-apa law. Okay, jadi kat sini dia dah katalah Q dia adalah kosong. Without heat transfer. No heat transfer, Q is equal to 0. So, delta U is equal to negative W. Okay, dalam adiabatic ni, adiabatic expansion maksudnya daripada volume rendah kepada volume yang tinggi. So the work done by the gas into the surrounding lead to corresponding decrease in the internal energy. So nampak tak delta W? Delta W means negative W. Okay. So in this internal energy, so delta U adalah negatif lah. Okay, in adiabatic compression, maksudnya perpindahan volume dia adalah daripada volume 2 kepada volume 1. Maksudnya, okay, kalau you buat work kan, work sama dengan work kan sama dengan kita kena tengok lah. Kalau delta W dia negatif, maksudnya delta U adalah negatif jugalah. Okay, so kalau adiabatic compression, the work done in the gas result in the corresponding increasing in internal energy. Sebab bila compression terbalik daripada yang equation ni, you akan dapat delta U adalah positif. Decrease in internal energy indicate by the decrease in temperature and the vice versa lah. Sebab kita consider atas temperature kan. Internal energy kan bergantung kepada temperature. So kita boleh kira lah based on equation of adiabatic ni, selalunya kita akan buat calculation based on dia punya delta U. F over 2 and RT. Okay. Maksudnya kita akan buat equation F over 2 and R change in temperature. Selalunya. Okay. Alright, so remember that we have 4 process: isothermal, isovolumetric, isobaric and adiabatic. So isovolumetric ni nama lain dia kita boleh panggil isochoric.